back. Today's the 21st day of continuing our daily Leetcode streak for the daily question of the day. Today we have Leetcode number 2311, 2311. Just call it the longest binary subsequence less than or equal to k. Okay, so we're given a binary string and a positive integer, and we want to return the length of the longest subsequence of s that makes up a binary number less than or equal to k. Okay. The subsequence can contain leading zeros. The empty string is considered to be equal to 0. A subsequence is a string that can be derived from another string, deleting some or no characters without changing the order. With that, also possible, which are equal to 4 and 5 in the decimal respectively. Okay. K1 output 6. Really? How is this 5? 0, 1, 0, 0, 0. Okay, wait. Okay. So we probably should start from right to left, or go from right to left in this. Check out the hint, because it would be easy if it would be at least easier if it wasn't subsequences, because with subsequences you don't really have a starting point. I guess you could start from right to left, but then if that's not most optimal, you have to move on and on. That shouldn't be too bad. Let's get one hint. Choosing a subsequence from the string is equivalent to deleting all the other digits. If you were to remove a digit, which one would you remove to reduce it by? Obviously 1. So you can remove all the ones. So we obviously want to start from the end of the string. The s minus 1. And then we want to go until once si. What? Why did that not print anything? Okay, why is this not printing anything? For range. That's because we need to make step -1 to go backwards. Okay, yeah, so that's what I thought. So we need to actually make this -1 because the end is exclusive. And then this should have all the characters, or all the letters in the string. Beautiful. Okay, now we're iterating from right to left throughout the string. So probably want to keep the current current value in a variable, and then also current multiplier, 0, 1. So if you do not know in binary, so we have the decimal system, right, our system, which it's just the rightmost is the ones value, right, from 0 to 10, and then as you increase more digits, each digit adds 10, or multiplies 10 to the last one. So this is 1, we add another digit, this is 11, which is 10 times, or this 1 is 10 times more than this other value. We add another one, 111. 100 is 10 times more than 10. We add another one, 1,000, you get the point. But in binary, there's only two digits, 0 and 1. And each digit that you add multiplies the previous one by 2. So this is the ones place in binary. You add another one. This multiplies by 2, like the decimal system multiplies by 10. So this would actually be, this value would be 3. This would be a ones place, so 1. And then this would be a twos place. So 2 plus 1 is 3. We can add another one, which would be 3. We already know this. You multiply by 2 again on 2, right? This would be 4. So this would actually be 7. And obviously you can add zeros in here as well. And adding a 1 here would be, this would be 1 place, 2, 4, 6, 8, I'm counting up by 2. 1, 2, 4, 8, 16, 32, 64. So this place would actually be the 64th place. And we already know this is 7. So this number would actually be 71. And we're going to try to do that process until we reach K, right? And then we need to compare that with our current max. Or no. Yeah. Because we don't have to start at the very right. Especially if there's a lot of ones at the very right. That's the only difficulty I'm having in coming up with right now. But let's just go with the flow right now. Starting from right. Yeah, so each one, we probably want to add the multiplier at the end. So current multiplier. I think I spelled multiplier wrong here. That seems more right. Current multiplier times equals 2. Or maybe to make it more descriptive, we can say binary multiplier. Binary multiplier times equals 2. And here we can say current value plus equals current value plus equals or is it times equals? So we want current value times equals, no, current value plus equals binary multiplier times s of I. But we want to convert this to an int, and we just do this. And we probably need to put this in parentheses as well. Let's see if this correctly finds the binary value of each of these. 74. This one that says 74, let's check. So this is 1 place 2, 4, 8. So this is 10. And then 8, 16, 32, 64, 74. Yep. Our thing correctly did that. This it says 41. Check. 1, 2's place, 4's place, 8. So this is 9. 16, 32. 9 plus 32 is 41. Alright, cool. So we have it correctly finding the binary value of each of these numbers. Now we need to check. We need to check whether if current value is greater than new value, we can do this. New value equals current value plus this. And then we can say if new value is less than or equal to k, then we can set current value equals to new value. I'm starting to feel like you don't even have to do this. You could just see if it's a 1 or a 0. But new value is less than current value equals new value. Else, continue. But we want to return the length. Max length equals 1. I don't think we need this else. see how many we get wrong here. This is definitely not the correct solution. That doesn't seem like it should work. What is that? Why does that work? What? This is not right. This solution is definitely not right. What is this? Why did this get accepted? Sure. Because we're not even checking. We're just checking the first spot, right? We're not even using a nested loop or anything like that. I don't think this should have gotten accepted. Count value power. Yeah, I mean that's basically the same thing I have for character and reversed S. I did not know you could do reverse like this. That's pretty cool. If character equals 0, yeah, this is the one I was thinking of actually doing. Okay, I should probably learn what is like bit something operations, because they would come useful in times like these. It's not the first time I've seen operations like these in Leetcode, and I just had no idea what they were. I look them up and then I forget later, but okay, if character is 0, then obviously you keep it, you add count, else. If power is less than k, and value plus power is less than equal to k, move to the next bit. Wow, that's kind of smart. Wow. If power is greater than k, count all zeros we skipped before and ones we did. Should I go through this? Character with 0, sure. If power is less than or equal to k. Power is less than or equal to k, value plus power. Where are we updating value? Oh, because zeros don't add anything to the value. So that's an optimization that my code didn't have. You don't need to do anything if there's a 0. What I was doing is I was just calculating the binary value of every one, but you don't really need to if there's a 0. Then you add that. Why are you adding the... Oh my god, this is smart. Because you are just adding the power. In binary. It's either a 32 or it's a 0. That's very, very smart. And then you add counts. Else equals 1 to x and k. It's a very clever solution, and then you're using... you're going from the start of the string to... Count all zeros we skipped or any ones we could take. What does that mean? Count all zeros we skipped or before and any ones we could take. Actually, I have no idea what that means. Honestly, this is a much clever solution. Alright, I think I need help with chat. Chat! Chat, I'm doing problem 2311, and I need your help. Accepted. Few seconds, 5 minutes ago. This is the one I did. This was my solution. And I have no clue how it was passed. Chat, what do you gotta say to that? Solution simplified. Sure. The logic ignores all zeros to the left after k is exceeded. But zeros don't change the binary value, so they always... Oh! You should count number 3 and add bits from the right as long as... Chat, I need help. I mean, yeah. How many characters we can include in the valid subsequence current integer value of binary subsequence? We go from right to left. If the current character is a 0, we just add 1. I get that. Else... If power is less than or equal to k and value plus power is less than or equal to k. When bits contribute a value of power to the binary number, we only include 1 if doing so doesn't exceed k. This ensures that we're keeping subsequence less than or equal to k. Power is the same as power times equals 2. So they're just wanting to be clever like that. Use this instead of times equals 2. Power is greater than k in a single. At this point, we processed some rightmost characters and stopped when we couldn't add more. But we might have skipped some earlier zeros, which we can still safely include because zeros never increase value. Why? When would you... Where would you miss a 0 in the solution? I don't understand, because every time you go through the array, you're checking if it's a 0, and if so, you're adding it to count. So I don't understand where you miss a 0. Yes, every zero is counted immediately, so your right knows you have skipped while iterating. This line breaks the loop early once the current power of 2 becomes too large. Oh. So that break statement is why. And then you can just check. Okay, from where I left off. Interesting. That's a pretty difficult medium problem, yeah? Wow. Not intuitive. To make this more intuitive for me, I'm actually going to is okay. Yeah, let's keep it in. Oh. Okay. Not easy, I will say, not easy. Anyways, that is today's problem, everybody. Hope you enjoyed seeing me struggle once again, and see you tomorrow.